Hello, everybody. Oh, I guess I should make sure that the microphone is working. Okay, it's working. Nice. Ah, dang, it kind of ruins the beginning of a video. Anyways, when we left off last time, we had just designed the frame. It was a very simple frame. Most frames, the first time you build them, are very simple. You don't want a very complex frame initially for a prototype because really that's the job of the optimization. Unless you know exactly what you want your frame to change to be lighter in order to be more ergonomical, the first frame you build is it's just gonna be something that holds everything to it. Um, so now that we've designed it, the next pieces that we need to construct are actually these two here. How do we set up an exhaust system? How do we set up a dust reservoir mount? But before that, we need a frame to mount everything to, and we need to just basically mount everything to the frame so that everything is in one place, one solid unit. So that's what we will be doing in this video. We're going to take the frame that we have and we're just going to mount stuff to it. And we're going to have to do some modifications to pretty much all of the pieces because that's what happens. So what we'll start with is we're going to go ahead and I think at some point I created an assembly file. Maybe I didn't. Oh yeah, I've got this. That's the assembly file that I know we built. Yeah, we don't have a full assembly file because we did this layout drawing, which was giving us our assembly. So what we'll do here is we'll go ahead and open a our frame, and I'm just opening it now because, quite frankly, I know I'm going to be modifying it in the future. Well, the idea is this would probably be some kind of an injection molded plastic. This may be two pieces that are bolted together. That's part of adjusting pieces in order to make them manufacturable. But at this point, I just want this component to be plastic. We could have made it out of like sheet metal or something. And if plastic is not strong enough for what we need, we could do it out of sheet metal. Sheet metal would be fairly light. Plastic can be a lot lighter for the amount of strength that it provides, which is why I picked plastic. But whatever, that's all design decisions. So here's the front of the device, the back of the device. Our dust reservoir is going to be sitting back here. What we'll go ahead and start out with is we know that this big piece right here is where our fan gets mounted. So I'm going to create a new assembly file and we're going to just start to build this piece. Now some of the components are not going to look pretty. Just going to preface this right now. It'll look not pretty, we'll adjust it, then it'll be pretty again. But we have to kind of get through the process of just putting things together before we can get to where we're at. So first piece I'm going to put down is the frame. Now again, this is a fixed component, comes in as F. If you right click on this, you can set it to float. I don't remember how to do that, but one of these options is you set it to yeah, float. There it is. And so that unfixes it and allows you to move it. You generally want to have one component in your assembly that is fixed, not all of them floating. Now, what I am going to do quickly is, before I do anything, I'm going to go ahead and turn on my view, hide show, temporary axes. This is my only temporary axis for this component, but as I go in and add a few pieces, so here, first piece I'm going to add is I'm just going to put the fan mount in here. Okay, so assembly, insert components, browse, give me that fan mount. Fan mount! And we could make this into an assembly if we wanted to. You'll notice this already has the bolt holes for attaching the intake, which we're going to have to cut the intake out of the frame. We'll make that adjustment though. I'm going to go ahead and put this fan mount in place first before we start doing any adjustments, because I will need to get the intake. You know what? No, I'm gonna put the intake. Whoa! Don't know what I just clicked on. I'm just gonna put the intake on top of the fan mount, so it'll connect right there. It's not even the right orientation, but that's fine. I know that this and this line up, and that'll actually do a lot to set my mates. So when we go to mate our intake to our fan mount, here I've got my temporary axes turned on. Again, there's a reason for that. I'll go ahead and select this axis and this axis. It flips it upside down. To switch the direction here, I just do that way, so now it's lying flat in that direction. If we do come up with a mate, we need to go fix it. Here I've got one mate. I can go in and I can edit that mate, and that'll allow me to shift what I have. Oh, this is moving all as one component because I never fixed the fan mount. Whatever. Okay, I'm gonna add a few more mates. I'm gonna stick this intake so that you only have to mate one of these holes. If you mate both of those holes, it's actually over constrained. So here, if I hit coincident on this, it's not doing anything. They may be slightly misaligned. So here, can't be successfully created. Cancel. It means that they just aren't, they're not aligned. Let me try to do it with the other one. See if I, yeah, no, they're slightly off, which that's not as much fun. So I could go in and I could adjust those holes. In a good solid design, you're gonna want to. However, I'm not caring nearly as much. So what I'm gonna do instead is I'm gonna make this line here with this line here. That's gonna set them to be coincident, which means they'll just be in the same plane. You could also do concentric, it'll do the exact same thing. Coincident actually brings them down so that they're in the same plane. It's basically just I mounted them to each other. So we'll go ahead and hit OK. Let's see if I can't drag this. Come on. Shake. I'm going to set this component to be fixed real quick so that I can modify this a little bit more. So here I'll right click on this, fix. I can always adjust that later, but that'll allow me to move my components relative to each other. Now here, my holes don't perfectly align up, and that is a problem. Yes, I am aware. So to get around that, what I'm going to do is I'm going to go into View, Hide Show, and I'm going to see if I can't get some of my planes to show up. So I built a lot of these off of planes, and what I might want to do here is I might want to create a plane that goes through the center of this object so that I can align this axis to it. As you'll notice, if I jump to this view right here, those holes are almost there. They're just not perfectly aligned. I didn't give exact dimensions for how to cut each of these. I think I rounded off by 2 decimal places, and SolidWorks doesn't like that, quite frankly. SolidWorks just does not have any kind of appreciation. Dang you, SolidWorks. So, oh, that kind of sucks. Let me see if I can't mate these two circles together. Here, that edge. Select this edge. Yeah, it won't do anything because they're not exactly identical. Ah, dang. If I went back and I identified them the same way, then I could put them on top of each other. Which is probably what I should do, but that would involve me going and measuring one part, and then measuring the other part, and then making sure that they're both the same. So let that be a lesson to me. Don't do that. So instead of aligning those, because they're close enough in my book, which is terrible, what I will do is I'm going to open up my fan mount, and I'm going to create a plane that goes along the center line there. Going along the center line will just allow me to align that axis to it. I'll just create a plane, and I will just make it coincident with the front plane. Fully defined. Go ahead and save. And then in SolidWorks, just jump back into my assembly. It'll ask me if I want to adjust it, and yes, now I have a plane. So now that, since I have planes visible in this drawing, I can select this plane that I just created, which shows up on fan mount, and then select this axis here, and then I'll just set them to coincident. Now what that means is I just basically lined this up with the center line of here. These holes are going to be almost perfectly on top of each other, but you can see that there is a little bit of an edge, which means when I put them in, like 0.002 inch off distance. But that's all SolidWorks needs. It needs exact distances in order to make parts. So we'll have to keep that in mind as we move forward with assembly. Now I did fix this part in order to connect it. What I am going to do is I am going to unfix that part so that I can bring in a fan component. Here, this is the hole for an axle. I am going to have to adjust this because there's supposed to be a gear on the other side. I haven't built the gears yet. I could very quickly build those gears so that I can connect my motor to my fan. I think I had a 1 to 3 gear ratio. And I put in my layout drawing how big I thought those gears were going to be. But I'll have to create those at another point. What I am going to do here is I'm going to figure out how I cut these holes. And I'm going to cut those, well, I'm going to just cut this entire shape out of the of this mount, because I'm going to need it to be absent in order to put this component on. So I'm going to do that. I'm going to open up the intake. And I've already got my frame created. So I'm going to take some measurements here and use them to adjust my frame. Alright, so go to evaluate, measure. I want to know what the distance is from this line to this line. Distance is 4.7 inches. Okay, I'll probably make it 4.8 inches just to give a little bit of tolerance there. So, it starts at the center line of this circle, which I have that center line established. This radius here is 5.5 inches. So, I have a 4.8 inch square that's cut out at 5.5 inches. So when I go back into my frame, I should be able to cut that out. So we'll start over here, where this is where my fan mount is going to sit, and I'm going to cut out where that intake is going to lie. We'll do a sketch on that face. I'll then zoom into that face. There we go. And I got my circle at 5.5 inches. That was a circle at 5.5, wasn't it? I believe so. Yeah, it's a radius of 5.5. Which is going to cut out of my actual frame, which is okay. It'll end up cutting down a little bit. So, go back in here, set this distance, come on, at a radius of 5.5 inches. Here, instead of doing a diameter, I could do a radius, but otherwise I'll just do, diameter is 11 because it's twice the radius. And that's where my intake goes out to. And then what I have is I have a line that comes from here, goes horizontally to the origin, comes down, and then also goes over there. So that's the shape that I'm cutting out for my fan mount. You'll also notice that we have little tabs in here. Yeah, we have these little tabs. I'm gonna need to cut those out too, because I set my frame to fit exactly up against my motor mount. Now, an easier way to do this would probably be to actually just mount the frame directly to the intake rather than cut out the frame. But I would prefer to mount to the fan mount, because the fan mount is the piece that's going to be a little bit more structural. The intake isn't nearly as structural as the fan mount. A fan mount is actually a giant brick. It's holding the fan. So that's just how I'm doing it. You could just drill a couple holes in the intake. You'd want it to go into solid material, so that's not just going into the air duct that's in there. But you could drill a couple holes in it and mount the frame to it. You could extend those tabs up and then mount the frame to those holes itself. I don't want to do that. So yeah, that's why I'm not doing that. Actually, what I might do is slide the frame underneath those tabs. So basically I would slide the intake on top of the frame. Yeah, I might do that. Huh. Problem solving there. So I don't need to cut out the tabs. I won't cut out the tabs, because you'll see what I'm about to do when I do it. It does mean I'm probably going to need some kind of a seal to go around the intake, because I'm mounting the intake on the outside of the frame, but that's whatever. Alright, let's finish. We'll add some relations here. I'm going to zoom in. It's like this point. It's like this point. And I want them to be vertical. Okay, that'll set them aligned. Hit OK. This line here is vertical and coincident with the center line, which is where I want it to be. All you need to really do is set this distance equal to, I think I had it at what, 4.8? So that we'll do 4.75. So there's a little bit of a gap outside of the intake. And that's all fully defined. So what I'll do is I'll just go ahead and I'm going to do one more thing. There is a circle here in the center I'm not sure what it is, but this is actually for the axle itself. I am going to cut out that hole because then I can slide an axle on or something. I don't know, I'm just trying to model what I have. So we'll figure out what that dimension is. Click on it. It's a radius 0.25 inch, so a diameter 0.5 inch. So going back here, get out of my measure, go back into my sketch, smart dimension this, and set it to have a diameter of 0.5. Okay, then we'll get out of this and do some trims. We'll trim this. Come on. And there we go. Now again, this is fully defined. The constraints carried over, SolidWorks made them carry over. I will finish off by cutting out this circle and exit sketch. Now I want to go measure how far this piece comes down. So I'll go back into my intake and I'll do a quick measurement. I want to know what the distance is from this line here to this line here. So measure this line to this line. Try that again. This line to this line. Okay, so in the Z direction, that's 7.25 inches. So that's what I'm going to want to cut down is 7.25 inches so that these lie about the same distance. So go back into my frame, and when I do an extruded cut, I'll do an extruded cut that is 7.25 inches long. Now we'll make sure that's cutting in the right direction. It is. And there we go. Yay! Now I may actually need to make that like 0.25 inches longer because I'm going to. No, I'm good. I'm good. I'm fine. Now I'm gonna go ahead and save this quickly. Always a good idea to save in case your program crashes. How much you're asking it to do simultaneously. It's gonna ask to rebuild. You'll notice that that piece is now missing because I cut it out. So what I'll do is I still have that axis. I'll go ahead and mate. Feel like some Australian. Come on, let's mate. I want them to be coincident. Oh yeah, shoot. I still have the component fixed. Fan mount is fixed. As long as it's fixed, I won't be able to. I will not be able to do any kind of mating. So, now that that's fixed, well now it's unfixed I should say, I fixed fixing it. Now we should be able to align these axes. Okay, and generally that's where I want it to be. So we'll hit yes, and then what I'm going to do is I'm going to set, okay, I want this face here, I want it to be parallel to this face here. I'll hit OK. And now what that should allow me to do is grab this intake and kind of slide it way out of the top here. So what I will do as a finishing piece, I don't want to grab onto plane 2. Oh shoot, this is all upside down. I'll fix it. But what I want to do for a finish is I would actually like to mount this face here to the top face up here. I'll hit OK. And now we will need to go back and fix that one. So here it's this right here. I will edit it, and I'm going to flip the direction of the mate like this so that it's just flipped over. And it's going to ask me to go back and fix that one now too. Alright, so I will fix this one. Oh no, that's not what I want. Just turned everything around. Don't do this to me. So I'll fix this last one. Okay. There we go. Ah, so it's got the right orientation on one of the mates, but now it's a, oh shoot. Not what I meant. SolidWorks is just trying to take all of the mates that I'm asking it to do and kind of reconcile them, which is why some of the mates change direction. We just have to go back in and fix those directions. So I'll fix this one quickly. There we go. Now I think, yep, now my fan mount is backwards. So that's fun. This is the one that I need to fix, because this is where I fixed that center line to the other one. I can't switch the direction of it. Well, that's sad. Oh well. Sadness. I'm gonna have to delete that one. Delete. So that I can rotate this one and realign. Mate. I want this plane here to be aligned with the center line of this hole. Yep, and that is the correct orientation. So I hit OK. And there we are. I now have a massive fan mount sitting inside of my frame. My frame may not be large enough. I may need to extend it. But I have my first component in here. This is the outlet that will feed into my dust reservoir. This was a lot lower than I thought it was going to be. Huh. Oh well. Guess we'll just keep going. Okay, now I do need to figure out how I drew these two holes in, and I'm going to go ahead and mount those to the frame itself. So basically it'll just be clamping down onto the frame and going into the fan mount. So if I just recreate the way that I drilled these two holes, let's see, where are you? If I recreate my sketch that I used to create this one, shoot. 3/8 of an inch off of that. That was a terrible decision on my part. I'm going to dimension this instead of to where it's at. Delete. I'm going to dimension that whole distance relative to, here's the center line, I'll measure it relative to the origin. That will make it substantially easier. 2.72 inches. Exit sketch. And I believe that's actually what I had it on the other one. It's 2.72 inches. So now when I go in back into my frame, I need to create holes that are 2.72 inches and whatever distance away from the origin. So we'll do one more sketch. Actually, you know what? Yeah, we'll do another sketch. Sketch on this plane. Draw a circle. I'll dimension this. It's 2.72 inches from my origin. I'm going to go perpendicular. Trying to draw at a weird angle. There we go. Now we can select the origin. .72. And if I go back in here, I am going to be going into this one again. It's 2.72. This is an inch and a half. I have no idea where. Center line. Oh, it's the center point of that. So I'm just going to do a quick measurement. From this center axis to this one. Should be a nice measurement because I used nice numbers. So here, the DX direction, that's what, 2.49 inches. Why are you doing this to me? Why did I screw that up so much? I'm just going to go back in and edit the sketch to make it a nice distance. I'm still in the sketch. I think. Yeah. Ooh. I escape a bunch of times. And here, this is coincident. That sets those two together. And this is the coincident that says, take the midpoint of this line and make them be equal. So if I delete that midpoint, I can now set the center point of this relative to this. And I'm going to force that to be 2.5 inches. Other than 2.48. So now it's asking me to rebuild and repair it. And it's saying that there are issues when it comes to boss extrude 5 that no longer exist. So it contains dimensions, so I'll have to go back in and fix this quickly. Here, apparently, yeah, there was a point there that is no longer there. I don't know why these things extruded so far downward. I'm going to ignore the error for now. Close. I'm going to try to figure out why that extruded so weird. It was supposed to extrude this direction, like 0.25 inches. I don't know why it didn't. Why did you decide to fix that, huh? Yeah, 0.5 inches in this direction. What it probably means is that this here took the full profile of what I had and extruded it rather than, you know, because this is no longer a closed shape. Got it. Okay. Alright, so that did cause a few problems when I changed this to 2.5, ironically. So if I go back and change this, I'm just going to set this, instead of it to 2.5, I'm going to set it at 2 inches. And that should fix my problem. So 2.72, 2 inches, hit yes. That should fix. Yep, my whole drawing then adjusts and fix itself. So I will need to go back in and fix my fan mount, no matter what. I was trying to avoid that, but apparently I have to. Oh, and I already had this file open. Nice. Well done, me. Alright, so I have to take these two holes and I have to fix them. Because right now they're not in the right place. So this line right here is what, 4.72? Hold on, I'm gonna find it. So if I go back into my intake, I just set these distances. According to sketch 5, it's 2.72 inches, which makes this 5.44 inches between here and here. So 5.44 inches, and they're 2 inches away from that center line. Okay. So instead of 5.45, it's now 5.44. The whole. And instead of having a construction circle, instead what I did was I just dimensioned this and set it at 2 inches away from the origin. Which I apparently need to go zoom in to this. Yep, and set this now to 2 inches. There we go. I don't know why these suddenly circles are showing as blue. I'm not really sure why. Huh. Oh, it's duh. I have to add one more constraint, and that is that this center point here and this origin have to be horizontal. And that fixes that. Alright, so now these holes are in the exact location on the fan mount. Whoa. Yeah, fixed it. So I'll go ahead and save. And now we need to put these holes into the frame. So it was 5.44 inches between the holes, or 2.72 inches. And they were located at 2 inches relative to the origin. And I think these holes were something like 3/16. I don't know, I'll need to go look that up quick. Let's pop it open. How big is that? Yep, it's a 0.1875. So that's right. Yay! So there we go. We'll just mirror this one feature. I'll create a construction line that'll go between here and here. Escape. I have a construction line, and then I will just simply click on this, mirror entities about. Whoa, nope. I don't want to mirror the line. I want to mirror about that line. Hit OK, and now it should be fully constrained. So I'll exit sketch, and then I'll just punch those holes. So extruded cut, and here I could just have them go down an eighth of an inch because that's how far they go, or I could just have them go down a ridiculously large amount. I'm actually just going to have them go down 1 inch and hit OK. It'll be more than enough too if I change the thickness. Those holes would still go through. I don't imagine myself making this frame more than 1 inch thick. So, all right, there we go. Now I have all of my. Apparently, I'm opening Google now. Now I have all of my fan mounts and everything created. This is telling me that one of my mates is now wrong. Yeah, because it's just one of these mates. So if I just delete this and rebuild it, it should fix the whole drawing. Yeah. Yep. So. Oh, I lost my hole. That was my problem. Why are you doing this to me? Sometimes making edits in SolidWorks causes your entire drawing to blow up. Nice work. Here, this line here, if I were to drag this line up, this is how it's called suppressing features. So here, if I were to just put this feature in here, all of these other things that I've already done are suppressed. If I grab this line and drag it all the way to the bottom, I unsuppress them. So I just needed to unsuppress my circle. I'll go ahead and save this again, go back in, and I will now have a circle to actually work with. I didn't need to delete that mate. Dang. Oh well. Not hard to remate. Put them in here. Select the axis. Go over here. Select the point. I probably could just align the holes now. That would be easier. But, oh well. Alright, so now we have an inlet into the fan mount. We need to put a fan in there. So I'm going to insert component. I will browse, go find my fan. And this one should be pretty simple. Here, this inlet here that I made, I want it to be up here at the top where, you know, the intake is. So I'm just going to go ahead and mate the axis of this fan with the center axis of this fan mount. I'll flip the alignment here because I want that one to be on top, and I'll hit OK. Now I will basically just set this surface to be sitting on the top of that fan mount. I can see the top of that fan mount right there. So when I go to do a mate, I can zoom in on this hole and select the top surface of that fan mount and the top surface here and hit OK. Now I can create an axle that go all the way through the fan. But I have my fan sitting very comfortably inside of my fan mount. Except it's not sitting comfortably because what I just found out is that my fan is as wide as my fan mount. And that's a problem. There's kind of an inch like interference. I thought I put an inch separation there. I'm gonna need to go back into my fan and make it a little smaller so that it fits nicely. It also looks like my fan mount might be a lot larger than my fan actually is. So I may need to shorten my fan mount. Let's measure what the distance is between these two faces. Center distance is 3.5 inches. So I have 3.5 inches that need to be on the inside of my fan mount. Okay, so let's fix that first. We'll go into the fan mount. And here, I think this is an inch thick. I measure this line. I'm going to measure. Yeah, that's an inch thick. So if this is 3.5 inches tall, I need this to be a total distance of 5.5 inches tall. So I'll go into my first extrusion. Here, I'll edit the feature. It's an inch longer than it needs to be. So I'll just shorten it up. 5.5 inches. Hit enter. Now, is that going to cause me some problems? Partially, yes, because now my fan outtake is kind of massive. It is what it is. But I am not going to adjust that. Well, I am actually going to adjust that. See there? I don't need it to go up that far. So what I'll do is I will go into where I defined that hole shape. I'll edit the sketch. We'll zoom in to here. Escape. What I want this to be is I would like this to be not a ½ inch from the top. I want this to be 1 inch from the top. It's kind of interesting. I thought that I set this to be the exact same width as this thing. Apparently not. So I exit sketch. It goes out. A lot. ½ inch longer than it should. That's weird. Alright, so we'll go back in here and edit the sketch again. I'm going to have to delete some of these relations. That relation's fine. That's actually the one that I want. This is, I think, what's causing the problems. So what I'll do is I will set this. Oh. Let me zoom in on space. I'm going to set this line and this line to be horizontal. So this line, control click this line, set them collinear. Hit OK. And now when I exit sketch, it will rebuild it so that the fan mount does not extend upward at all. Okay, then I can go ahead and save. That solved two of my problems. Last issue that I'm going to have here is that I need to cut this hole in the bottom so that my axle can come out the bottom of my fan mount. So I will create a hole in the bottom. I will zoom to the bottom. I will draw a circle and set this to be 0.5 inches. Eventually I'm going to create an axle here. But then my axle is going to come out, go into a gear that's going to be on the bottom side of this, connect to another gear that connects to my motor. And that's my goal. So let's do a quick extruded cut. Here I'll just have it cut down an inch again. I could have it go 2 inches, I guess. I'll never make my fan mount wider than 2 inches. Otherwise I could do up to face and go select the bottom face of the fan mount. Alright, save this again. Should have fixed all of my issues with my fan mount. They'll ask me to rebuild it. Oh no, I didn't fix anything. I didn't fix the fan at all. I have to go back into my fan and cut it down by like 2 inches. Yikes. Yeah, because when I made my initial spiral, it was there. But then I extruded along. Yeah. What I'll do is I'm going to adjust my fan blade so that it's not 3 inches out, but actually 2 inches out. Exit sketch. That should just make the whole thing shorter. Yeah, that should have fixed the whole thing. So I'll hit save. The nice thing about designing these well is that when you have to go back and edit them, you can. It'll update, and now my fan fits very nicely inside of my fan mount. You can see it right there. It's hiding inside of this assembly. It's where it wants to be. Alright, now we have this hole in the bottom where we're going to have a couple of gears, and then we're going to go ahead and mount our motor mount underneath this. So let me bring in the motor and the motor mount so that we are ready to make some adjustments there. Now here my motor and my motor mount already have some holes in them. So I will not be struggling to identify where to mount them to, because I already have like, what, 8 holes there? I'm just going to have to create 8 holes in the bottom of this frame to mount to, and they've got to be in that same circular pattern as I created them earlier. So then we'll go and let me insert components. We'll get the motor mount in. And you can build sub-assemblies and then put an assembly into another assembly, which sometimes makes things easier. So here, if I would have made that fan mount, fan, and intake assembly, I could have just inserted it into the frame just like that. I didn't want to, but I could have. So here we got these components here together. First thing I'm going to do is I'm going to try to make Oh ho. Oh ho ho ho. Ho 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 ho. I don't want to make the plane. I might turn off planes for a second. It starts getting annoying. I'll make the two axes together. Turn off planes. Dang it, planes. You and your vroom vroom. And then I will go ahead and set this axis to this axis. Now, once again, I did not line those up well when I created them. So I'm actually going to go in, look at how I created the holes for the motor, and adjust how I'm creating the holes for the motor mount. So, as I told you, as promised, this is a lengthy process trying to figure things out. But once I get the motor mount and the motor installed, I will be done with most of the assembly for this. We'll do another assembly drawing after this, but assembly just takes a while because you have to do some modifications. Those fun pieces. It just takes time. Alright, so I got my circular pattern. I got my cut. How did I identify my cut? Well, it looks like I set him at... I'm going to have to edit that sketch. Yeah, it looks like it's at a center point here. Instead of doing that, what I will do is delete this. And then create a construction line that goes to the center. So here to here, sets up as horizontal. I'll do a smart dimension, and I'm going to set this at 2.09 inches. No, 2.09 inches. Okay, 5. Nice. It's at the exact same place. And now this one, I'm gonna delete this because it was a generated mirror that kind of broke when I deleted that other line. So I'm gonna just reset this mirror and hit OK, and then it'll be fully defined. So nothing actually moved there. I just redefined it so that it was a measurement rather than an actual connection. So now I will open up my motor mount and I will define it exactly the same way. If I do that, I should be able to align those holes. All right. So here, zoom in. It was 2.0925 between here and here. How did I establish the horizontal location? That's weird. Symmetric. Alright, we're just gonna throw a dimension in and see what freaks out. 2.0925. We'll leave it as driving. And it's gonna tell me that there's some issues here. Oh, that's right. Because it wasn't in this drawing that I had this problem. So I'll just delete this dimension. I have to fix where these points are in my extrusion. Where are you? Dun, dun, dun. Oh, I gotta exit sketch. I can edit this sketch. Alright. Oh, I had this. This is tangent. Okay. This is symmetric. Okay. This is coincident, and I set it coincident to this piece here. If I delete this construction line, what I'll do is I set this at, oh, and then I'll just replace it with a dimension from here to here, and this is 2.0925. So close enough, but not close enough. Exit sketch, and that should fix everything. Yay! File save. Now I should be able to align those holes. So I'll go back into my assembly. It'll ask me to rebuild it. Or it'll just automatically rebuild it. And now I should be able to mate this hole to this hole. Okay, so a nice piece about that now is that I can slide it in and out, but I can't do anything more. And now the last piece is, since I can slide it in and out, I just need to fix this face to this face, as if it would be clamped together. So I'll select that face, and I'll select this face. Yay, and now they're clamped together. And I can see all the way down those holes, so I can go ahead and I can create those exact same hole patterns in my frame. Let's try to position this. So here I'm gonna mate this face here. To this face here. That is the orientation that I want. So I'll hit yes, click out of the mate menu, and we'll move this right there. So, is this in the position that I want it to be in? The answer to that is yes, actually. That is right where I want it to be. My frame is the right size. This is why I did the layout planning. So now what I'll do is I will identify using this axis, which is this. I want it to be something like 4 inches away, something like that. I don't know, I'll pop up my layout drawing. And once I'm done with this, now I have to connect my piping. I'll have to cut a hole in the back so that my piping can go out and into the dust reservoir. But once I'm done with that, I am mostly done with my assembly, and I am nearly ready to maybe put a plastic body on this, put a handle on, put a switch on, put a charging port on, be good to go. Drop all my battery and all my components in, and just be done. We're getting there. Alright, so here, according to this view, oh, it's going to freak out because I'm running SolidWorks and AutoCAD. I'm running a lot of things in SolidWorks. And there's one thing in AutoCAD. So here, if I go in and dimension, that is a diameter of 1.5. This has a diameter of 0.5. Ooh. So diameter of 1.5. We'll I might make that a little bit bigger. I might double those. because I think my motor axle itself a little bit bigger, but it is a 3-to-1 ratio. So I want to measure what my motor axle is real quick. I think it was like half an inch. Evaluate, measure, give me that circle. Diameter is 0.32 inches. So yeah, I'm gonna make a gear on this that's gonna have a diameter of an inch, and then my other gear is gonna be 3 inches in diameter. Which means if it's 3 inches in diameter, it's 1.5 inches. Basically, it's 1.5 inches from that axis to the outside point of the gear, and if this is 1 inch in diameter, it's ½ inch from the center line of this to that. So 1.5 inches plus ½ inch means I'm going to be offsetting this by 2 inches. That might make more sense if I actually, built them. But all right, so here I'm going to do a sketch. I'm going to do it on this plane back here because this is where I'm going to be cutting my holes. Sketch. I will zoom in on this back plane, and I'm going to draw a line first of all from here over, and this is going to be 2 inches. Oh yeah, trying to draw it like AutoCAD. This, I'm going to set it to be construction. I'll dimension it to be 2 inches. So this is the distance from the center line of the axis of my fan to the center line of the axis of my motor. The distance in between these is going to be fit in with 2 gears. Okay, so now what I will do is I'm going to draw my circles the same way that I had it on my motor mount. So here I drew a line over, a line up. Both of those are for construction. Should have just set that before I drew them, but whatever. Whatever. Now I'll give some dimensions. This one was something. I don't actually remember what that was. I'm going to pop up my motor drawing really quick so that I can look at what the dimension was. .0925 inches, and then it's 0.2 inches up, and this is a 0.16. Well, I'm just gonna make it up. 0.1875 inch. It'll still fit the same hole. Okay. So this is 2.0925. Enter. This was 0.2. And then there was a circle for her. The dimension of that circle was 0.16 inches. Okay, so I'll click out of Smart Dimension, and then I'm going to mirror this circle about this line as I did before. And then I will exit sketch. I'm going to go ahead and cut these quickly, and then I will do a circular array about the center point right there. Which I guess I could have done. I'll just do that right now, while I have that point in the sketch. So here, linear sketch pattern, circular sketch pattern. Entities to pattern, this circle, this circle. Okay. I don't actually want it to be the origin. I want it to go about this point right here, which is the one that's the axis, the center axis of that motor. And there we go. 4 of them around 360 degrees. That's what I want. Perfect. Looking good. Go to exit sketch, and then I'll just cut all these holes at once. Features, extruded cut. Let's see. Selected contours. I'm going to go try to actually select sketch 5. And it should get all 8 holes at once. We'll do a blind 2-inch extrusion. I'll hit OK. And there we go. I now have my 8 holes. Now I can mount my motor mount directly to those. Huzzah! So I'll go ahead and save this again. Save intermittently. Go into my assembly. It'll ask to update. I'll say yes. I've already fixed the bottom face of my motor mount. Whoa! Already fixed the bottom face of my motor mount to my frame. So now all I need to do is I'm just going to align 2 holes. And I can pick out really any 2 holes to align. And that will fully constrain this. So here I'll pick that axis. I'll zoom over here and that axis. See, that one can go right here and mate to this axis. We'll hit OK. Now everything's pretty much aligned. I'm just gonna grab one more axis just to make sure. So that one will coincide with this axis here. And there we go. Everything is fully defined. Now I will not be able to grab this motor mount and move it. It is fully defined. So again, all you need is 2 holes. Everything else is actually redundant on this design, which is poor engineering practice, but the redundancies also mean that we make sure that this thing doesn't ever remove. Now I will need to make my 2 gears, and I will need to make the axle that goes all the way through this. But yeah, thanks for reminding me to save SolidWorks. I don't think I've ever saved this. Save all. We'll give us a name of, this will just be our full assembly. I call it full assembly. Alright, I'm going to go ahead and end the video here. We've got most of our components in place. Yes, we do need to make 3 components. Yes, we do still need to connect this to the dust reservoir, but I will do that